of finding all characteristics to graph. So I'm going to give you an equation, and you need to graph it. So I give you all of the pieces that we need. So the first one is your x-intercepts. And if you remember, that is where y equals 0. So I put in a 0, negative x squared plus 4. Now, if there's only one x, we can get it by itself and then square root. So when I subtract, I get negative 4 plus negative x squared divided by negative 1. I get 4 equals x squared. When x squared is by itself, or the squared term, I should say, we are going to square root. And that's where we get two answers. So we get 2 equals x, negative 2 equals x. And because x is already by itself, that's it. So now our x-intercepts are 2, 0 and negative 2, 0. Now, if you want to graph as we go, that's great. I'm going to graph all at the end. But if you want to graph those 2 points and kind of go from there, go for it. Now remember, your line of symmetry is x equals 2 plus negative 2, divided by 2. It's 0 divided by 2, which is 0. So x equals 0 is my line of symmetry. That's in the middle. Now, what's interesting about this one is the vertex is on the line of symmetry. So that means that your x value is already 0. So when I plug in a 0, it was plus 4, right? Yep. So that's 0. 0 plus 4 is 4. Now, when I do y-intercept, your x is 0 as well. So in this case, your vertex and your y-intercept are the exact same. It doesn't always happen like this, but sometimes it does. So, negative 2 and 2 are your two x-intercepts. And then I graph my line of symmetry. And then, my vertex, sorry. So vertex is 1, 2, 3, 4, which is also your y-intercept. So there's my graph for this one. So I found all the pieces. The pieces were just the same. The vertex and y-intercept were the same. Okay, so now here is vertex form. So our y equals 0. And here we have to do a little more solving than the last one. Now, here's the tricky. If you come across a negative square root, if you remember from last chapter, we said that was an I. It was imaginary. So I'm going to do I square root 1.5, negative I square root 1.5 was x minus 1. And then I just add 1. So my two x-intercepts are I square root of 1.5 plus 1 and I square root of 1.5 negative I, plus 1. Now, that's a little confusing, but imaginary numbers do not show up on the graph. So when that happens, when you're doing the line of symmetry, we're actually going to do it the exact same way, where you're going to add up the 2 and divide by 2. So, I square root of 1.5 plus 1 plus negative I square root of 1.5 plus 1 all over 2. Now, when I do that, I square root of 1.5 and negative I square root of 1.5. These two cancel out. It's like a negative 2 and a 2. They add up to a 0. So if I have a negative and a positive of the same thing, they cancel out. So now it's just 1 plus 1, which is 2. So your line of symmetry is 1. So do it again. So when you get a negative under the square root, remember the I. The I stays I. You don't need to simplify. So your x-intercepts just are I squared root of 1.5 plus 1, negative I squared root of 1.5 plus 1. When I add them together for my line of symmetry, I get a positive and negative of the exact same thing. When that happens, it adds up to a 0. So what you're left with is a 1 plus 1, which is 2. 2 divided by 2 is 1. So your vertex starts with 1. That's your x value. And then 1 minus 1 squared plus 3, I believe. Yep. So that is 1 minus 1 is 0. 0 squared is 0. So I get 2 times 0. So my vertex is 1, 3. Now, when I put in a 0, zero minus 1 is negative 1. Negative 1 squared is 1. 2 times 1 is 2. So my y-intercept is going to be 0, 5. So when you are graphing that, you can't graph imaginary numbers on the graph. You can only graph these 3 things. So let's first start with x equals 1. And then your vertex is 1, 3. And your y-intercept is 0, 5. And then I mirror it over on the other side. Now, when you have an imaginary x-intercepts, that means your parabola goes up or it goes down. It does not cross the x-axis. So if you get imaginary numbers and your graph crosses the x-axis, that means we did something wrong. Most likely you got the wrong y-intercept. But that's what it should look like. So